This is the first one on the back of your study guide. This one is going to be kind of difficult for me to show on the iPad because I can't put a calculator on here. The way I decided to do it was I let this be my X and this be my Y. And I used the letters because I didn't want to get confused as I was going through here. So I used the letter E instead of X, and I used the letter T for temperature for Y. And that's the way I'm going to write it down here. And the way that I make it X is I make this one be my L1, and I select that first when I'm doing my lin reg on the calculator. Same thing with this. This is my L2, and it becomes my Y. So you go through the process of finding the line as best fit, and I get temperature equals -0.00358 E plus 8 58.797. Now, one question that many of you will probably have is why did I write .00358 when I always say let's round to 3 decimal places, and if I round this to 3 decimal places, I'll just get .004. I would take that .004, but I like in this particular case using 3 sig figs because of accuracy issues. Either way, one second. So I wrote in the answer for part B. The key with the interpretation here is knowing rise over run and using my units correctly. So this tells me that for every increase in a foot of elevation, the temperature decreases, and I know it decreases because it's got a negative. It decreases by 0.00358 degrees. I'm going to hit pause and erase that, so make sure that you're good with that. Real quickly, that goes back to the Barbie Bungee thing that we talked about for a long time, and all that discussion that we had about what did the slope mean for Barbie Bungee. And if you remember back, it meant that it was the slope represented the jump distance per rubber band. So add a rubber band, how much more would she jump? Okay, so the y-intercept represents the temperature at sea level, because the y-intercept is the value when E, which is our elevation, is 0. So when I make E 0, that means an elevation of 0, which would be sea level. So this 58.797 thing is the predicted, based on our model, temperature at sea level. Part D asks us to find the elevation if the temperature is 32. So this is where using T and E in my equation, it's going to make things easier for me. I don't have to say, wait, what's Y, what's X? I've already kind of done that work. So it says temperature is 32. So I take the left side and I say 32 equals -0.00358 E. That's what I'm looking for. What elevation? Plus 58.797. So I am going to subtract 58.797 and divide by my slope. And I get my E is equal to 32 minus 58.797 all over the slope, which is -0.00358, which gives me, what does it give me? 7,485 0.196 feet. So, and then you should also ask yourself, does that make sense, right? If I look at the model, that would be somewhere, 32 would be somewhere in between these two temperatures, the 41, the 23. Does that fit my elevation in between the 5,000 and the 10,000? Yeah, 7,485 is like almost smack in the middle of the 7,000 and the 4,000. So, the last question says, what temperature does the model predict for the top of Long's Peak? And it gives us the elevation of Long's Peak. This, again, is where having my E and my T will help me out. They give me elevation and want temperature, so I'm going to plug in that 14,255 for E. So my T is equal to, I'm going to change colors. What am I going to change? Green? Does green look, There, we'll do black. I don't think I've ever used black. Alright, so my T is equal to negative 0.00358 times 14255 plus 58.797. Plug it in, multiply, blah, 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 do the calculator work. I get 7.764 degrees. Once again, I want to ask myself, does this make sense based on the model? Well, 14,255 is really close to this. And is that 7 pretty close to the 5? Yeah, it's good enough. Remember, so it's not, I mean, if it was like, if that 0.15 commas 15,000 feet and 5 was really close to my line, then it would probably be the 7.7 would be closer to the 5. But remember, it's a line of best fit based on the entire data set. So that this point right here may not be right next to that line. So that's that. Hopefully you're pretty good with this based on all of that Barbie Bungee work that we did.